So we have a differential equation, which is an initial value problem. So let's try to solve this differential equation. In order to do that, what we'll have to do is here dy over dx is equals to some function of x plus y. So that means we will substitute x plus y with the variable v, and then we differentiate both sides with respect to x. So that gives us 1 plus dy over dx equals to dv over dx. Then we isolate dy over dx. So dy over dx will be equals to dv over dx minus 1. Now we substitute dy over dx with dv over dx minus 1 into our original differential equation. So that will now become dv over dx minus 1 equals to secant of, so we have x plus y, so that becomes v, which is simply dv over dx equals to 1 plus secant of v. If we separate the differentials, then we should get dx is equals to dv divided by 1 plus secant of v. So we know that secant of v, so that's simply equals to 1 over cosine of v. So if we substitute secant of v with 1 over cosine of v, then we should get dx equals to cosine of v divided by 1 plus cosine of v dv. Now we can see that this is in the variable separable form because the coefficient of dv is entirely a function of v, and coefficient of dx, which is 1, is also entirely a function of x only. The integration of dx, that's pretty straightforward, that will give us x. The integration of the integral on the right hand side, there will be multiple ways to solve this. So I'll use the way as shown. So I'll use the half angle formula that cosine of v is equals to, that will be 2 times cosine squared v over 2 minus 1. I'll use this particular identity so that our integral now becomes integration. So in place of cosine v, we have 2 times cosine squared v over 2 minus 1 whole divided by, if we look at the same identity, 1 plus cosine of v, so that will be 2 times cosine squared v over 2 times dv. So we have 1 minus half times 1 over cosine squared v over 2, so that's simply secant squared v over 2, and this is integrated with respect to v. So that gives us x as equals to integration of dv minus half integration of secant squared v over 2 dv. So we have x equals to integration of v, so dv, so that's simply v minus half. Then we have integration of secant squared v over 2, so that will be tangent of v over 2 divided by half plus the constant of integration c. So we get x equals to, so we have v here, so v will be replaced with our value x plus y. So x plus y, so this half and this half gets cancelled, minus tangent of v, so v will be x plus y whole divided by 2 plus the constant of integration c. So here our x and x gets cancelled from both the left hand side and the right hand side. So we'll have y equals to tangent of x plus y over 2 minus c, right? Now we have to obtain the value of c, and we are provided with the initial conditions. So let's use that. So we obtained y equals to tangent of x plus y whole divided by 2 minus c, and we are given y of 0 equals to 0, which simply means that when x approaches 0, y is going to approach the value 0. So let's substitute this here. So we have 0 equals to tangent of 0 plus 0 divided by 2 minus z. 0 is equals to tangent of 0 plus 0, so that's simply tangent of 0, which is also 0. So that means the constant of integration c is equals to 0, and we substitute it here, and this gives us the final value y equals to tangent of x plus y whole divided by 2. So this is the required solution to a given differential equation. Thank you.